Hi, good afternoon. Thank you all for coming. My name is Jason Dando. I'm product manager for the Ethernet over Coax products at Ashridge. We're part of the Teleste group of companies, which hopefully some of you have heard of. So my section of the afternoon really is to talk about continuing the theme of Coax, talking about putting Ethernet over the Coax in our networks and homes and buildings, etc. Ethernet over Coax, obviously a really obvious thing. Coax is in just about every building, every school, every hotel, every wherever. And at the moment, it's massively underutilised. As we've said, it's everywhere. We can save time and money. Obviously, pulling Cat5 cable, I think we've already touched on, is potentially quite expensive, quite disruptive, etc. And you have this great medium that's already there. It's hugely underutilised. Often, sometimes with hotel environments like we're in here, if you said we want to come along and run Ethernet extension because you want better Wi-Fi, you want connections in the rooms, we're going to have to sort of shut your lifts for a day because we need to drop Coax, Cat5 cables down the lift shafts. We need to recable your rooms and start stapling cables on the walls. They're not going to have any of that. Whereas, lo and behold, they've actually got a completely functional Coax network to every room, to every point in the hotel already. And obviously we've seen, Wi-Fi is ethereal, it's through the air, it's very hard to nail down. Sometimes it works one day, not the other. So as we increase our demand for bandwidth and reliable data, Wi-Fi is becoming harder and harder on mass solutions. It's really becoming an in-room solution where you have the router there, the client there, and you're just sending a beam in a sort of visible line of sight. Wi-Fi over greater distances does work, but it tends to end up being a quality of service which is really suitable for web browsing, email sending, etc. So if the Wi-Fi is poor quality of service, your Google search takes a little bit longer. Your email takes 5 seconds to send as opposed to 2 seconds to send. That's fine. Nobody cares about that. But obviously our demand for bandwidth, our demand for online video, 4K video, full HD, etc. requires really, really good quality of service of data. And the only way to get that is using really local access points, either in the room or shared between two rooms, etc. And the best way to get that data to those access points is the Coax that already lives there. Very, very simple. So it's a case of twisted pair versus Coax. And ironically, most people have kind of overlooked Coax. But it's there, it's usable. I'd say Coax has a huge usable bandwidth as well, everything really from 5 to 2,000 megahertz. So there's plenty of space in there for everyone. Obviously we've got our DVB-T, DVB-C transmissions, etc. take up a proportion of that, but there's a great amount of space that we can actually utilise for other things. So by using Ethernet to Coax bridges, bridge being something that basically takes the Ethernet signal, is encoding that onto the Coax as a signal in its own proprietary format, and then at the other end, just taking that signal, turning it back into Ethernet. One of the questions that was asked this morning is, does the IP network, does it see those bridges? And the answer is no, it's completely transparent. So if you run a scan of your network, it's not going to see any of the bridges, any of the encoding, decoding. It just behaves like it's a cable. As far as the network is concerned, it's just a long piece of cable. It's that simple. And the irony of the whole thing is, Coax was actually used for networking long before IBM invented twisted pair cabling. Now I can see somebody already laughing there saying, I remember that now, yeah. The very, very first, I think, token ring networks, probably when we were all still children at school, used Coax. Is that right? Because IBM told us it was a good idea. The big blue said, and therefore we all said, okay. Yeah, they had a lot of good ideas, yeah. Maybe that's why they nearly went bust. But yeah, IBM were using, IBM introduced a twisted pair and it all kind of changed from there. So we can use EOC traffic. Basically, to get maybe 800 megabits per second, we need about 200 megahertz of bandwidth in the Coax. Not a huge amount, so there's plenty of spare space there. And obviously all of these systems that we're going to look at were designed as retrofit systems. Obviously if you've got a completely new build, then logic says, yeah, you're going to go and hoof out some Cat5, Cat6, Cat7, whatever, you want to dream up cable, fibre, everyone gets excited with that. But for the rest of the world, the other 90% where it's retrofit, these solutions were designed to pass through the existing splitters, taps, slightly questionable bits of old Coax, dodgy splices where people have hacked through it, joined a bit on, furry wall outlets, etc. So very simply, all of the systems we're going to look at have a huge dynamic range. They've got about 80 dBs of forgiving dynamic range in them there, so you can overcome a lot of the issues you're getting from distance, from things in the way, from splitters and so forth. And obviously people forget as well, because we've got used to this idea of aerial on the roof, receiver over there, that coax is a one-way street. Obviously it's not. It supports full duplex communication. It's a two-way street, so we can send and we can receive. It's quite happy with that. And then people sort of think, oh yeah, cable TV, yeah, that uses coax. It's the same thing. So coax really is a very, very flexible media. What type of systems are there? For the purpose of this, we can broadly classify them into two different types of system. First of all, we'll look at the through the home network, where we're concerned with basically everything within the same home. Your house, my house, their house. So basically we're sharing in a, if you like, a mesh network around the home, all of the data and information. So it's not a discrete network, so each bridge and node on the system can see what else is going on. So the Ethernet to coax bridges that you see based here and here and here, they're actually sharing, so the information is passing across the network, jumping from splitter to splitter, etc. So we've got a mesh network of sharing data around the house. So we can connect things like NAS drives, PVRs, IPTV, your cable modem, and everything is shared everywhere, and the data just takes the path of least resistance around the network effectively. And typically now with Mocha, which we'll come on to in a second, we've got about 400 megabits per second of bandwidth that we can get around to up to 16 points on that coax network. So you can actually have 16 bridges in one house. So that's generally, unless you're a Premier League footballer, that's probably enough rooms to be contending with. The other type of system is a to-the-home network, where this would be used for hotel rooms, MDUs, student accommodation, etc., where you have a discrete network where each of the CPE, customer premises devices, is only reporting back to a network controller. So that's a kind of a host and client network, as opposed to a sharing or mesh network. That's the big division. But you'll see upstairs in the breaks and the breakout sessions, we've actually got the two different networks set up on a tabletop, so you can get a better idea of how they go together and actually see some hands-on with that. Okay, so the through the home network, very simply, will give you 16 devices, and broadly those devices fall into two camps. There's the single Ethernet device there, which you generally plug into your cable modem or router, etc. That's getting Ethernet connectivity onto the coax. So it's an RJ45 Ethernet connection, plugs in there, that's then modulating the signal onto the coax connection. And you can see it's got a pass-through, it's got a diplexer in there, so your Ethernet signal is going back up the cable to the splitter and then propagating out around the house. And you've got a loop through so that whatever TV signal was coming out of the wall outlets, passing through that and then going onto the TV. And it's not affecting what's happening there. So the installation, very, very simple. Unplug the cable that's going into the TV, plug it into the Ethernet over coax bridge, fly lead from there to the TV or the PVR, whatever's there, and off you go. And at the other end, if we just want to connect a single client, same idea applies. Plug that in, Ethernet connection to the TV, PVR, games console or whatever. Or the bigger box at the bottom there, see the back, we've got 4 Ethernet ports and Wi-Fi as well. So that's supporting gigabit Ethernet, Wi-Fi. Our latest products are actually supporting the latest funky flavors of Wi-Fi, which apparently is 2.4 and 5 gigahertz AC standard. So we've got everything covered. Apparently all the Apple devices like the 5 gigahertz better. And interestingly, as we move to 5 gig, it's a nice clear space. There's less people on it if you run a channel scan. 2.4, if you run it at home, you'll see like 20 competing networks. 5 gigahertz, you maybe get 1 or 2. But the downside with 5 gig is rubbish at penetrating walls, floors, ceilings, water pipes and everything else. So you need to have multiple access points around the house. And obviously the best way to put multiple access points around the house is using the coax. There we go. Okay. So all the devices within that mesh network are basically both master and slave. So you don't need a network controller, they really are just plug and play. So you join them together via coax, little light comes on to say I've got a coax link, you're up and running. You just add your data and off you go. So there's no configuration, IP addresses, etc. It really is just plug and play. As I said, we've got Mocha 2.0 gives 400 megabits per second. And Mocha is a standard, it's a global standard that's ratified, and that stands for Media over Coax Alliance. And in the US, you'll see a lot of set-top boxes, cable modems, etc. already have the Mocha chips from Broadcom and Entropic built into them, but everything using that standard is compatible, so you can mix brands and makes, etc. together. Also, with the latest Mocha 2.0, if you just want to make a point-to-point link, you actually bond all the channels together and it will give you a 1 gigabit per second link between point A and point B. So very, very useful if you've only got an extension from one building to the other, or you need to get from the basement to the bottom floor, top floor, etc. 1 gigabit per second link over the coax, and you just break it out at the other end. But very, very simple. And the great thing with the Mocha standard is it's got very, very low packet error rate and loss as well, and it's optimized for the rigors of digital video. So it can move big packets very, very quickly, very reliably. You know, if you're running it over a sort of 2-week test, you will only be dropping maybe 1 or 2 packets within a couple of weeks. Very, very high error correction. It's all about retrofit. It's all about sharing digital video. Typical applications. The biggest thing we're seeing from our customers in Europe is Wi-Fi extension. You know, cable TV and telco operators are delivering this massive pipe of data to the front door, and then it's all kind of falling apart the moment it crosses the threshold. Typically, you have one Wi-Fi access point by the front door, pretty much the same wherever you come from. That access point then is trying to deliver that huge pipe of data all the way around the house. So it's good in the hallway, it's maybe good in the living room. By the time you get to the kitchen, it's getting a bit sketchy. Go upstairs and it's all starting to fall apart. And if you talk to pretty much any internet service provider, telco operator, cable TV provider, probably 70% of the customer complaint calls they get now are based or can be tracked back to Wi-Fi. Customer comes home, sparks up their iPad, won't connect because they're out of the range of the Wi-Fi, or they try to watch their premium on-demand video service and the Wi-Fi's not up to it, it's not working. Customer just sees, I'm paying 40, 50 quid, 50 euros a month for this, it's not working, straight on the phone to the provider, it's a big problem. So by doing a few simple steps of actually getting that big fat pipe of data moved around the house and delivered locally, you can actually get that 50, 100, 150 megabits per second, not just to the home, which was the big challenge a couple of years ago, but right into the customer's hand. Obviously, very importantly, most of the devices we're using now are going wireless. But the big drive for internet connectivity as well, if you talk to someone like Coax, they removed 2 or 3 years ago the Wi-Fi connectivity option off of all their set-top boxes, purely because Wi-Fi was killing their customer service support, tech support, etc. 90% of the calls they were getting were people saying, well, it worked yesterday, I've come home today and switched it on and it won't work because it had fallen off the Wi-Fi net. He's laughing at the back as well. It wouldn't work. And Coax will then say, well, it's your Wi-Fi, have you tried moving it? And people are saying, well, I just bought it from you and it doesn't work. So why not use the same cable that's delivering the pictures to actually deliver the Ethernet? You just put a coax bridge on there, plug it in, Ethernet connectivity, bang. You've got perfect Ethernet connection, no more customer complaints. So that's one of the prime things. Wi-Fi extension, whole house network, and obviously if you're putting multiple access points, very, very simply, just set all the access points to the same SSID and password. So as you move through the house, from the front, upstairs to the back, etc., your devices will automatically hand off from access point to access point. You're creating a whole house network. Or you can do as I've done, and you set, if you've got an office at home, set your own little SSID and password so the kids can't access your network when you set in your office and so forth. Very, very easy to do, very plug and play. Obviously PVRs with content sharing, we're moving to the age now where you have a master PVR which has got all the content on it, and then you have some IPTV players or even smart TVs that will share that content. Again, rather than relying on flaky Wi-Fi, use the coax that's delivering the picture to the TV anyway. It's there, it's coming out the wall. Just add the Ethernet to coax, mock a box to it, and off you go. Very, very simple. Obviously smart TVs as well, they all have Wi-Fi connection. You can actually go and pay 20, 30, 40, 50 pounds for a Wi-Fi dongle to plug into some of the older ones, or you can just try and use the existing Wi-Fi. Again, use the Ethernet connection, Ethernet of a coax. You've got perfect connectivity there. It's always going to be on, always going to be working. So a typical through the home network, quite a diagram there, but you can see we've got the TV aerial goes into a splitter up in the loft. We've got various drops of coax going to the rooms. Down at the bottom there, we can see we've got our router, goes into the first mocker box. That's just connected to one of the outlets of the splitter. So we don't need to change anything up in the loft. We don't need to put that into the input side, etc., because the mocker signal is going to hit, the Ethernet, the coax signal, sorry, is going to hit the splitter. It's going to jump across the legs of the splitter, propagate out to the other points of the network. So then suddenly, all of your other coax points around the house have the mocker signal on them, Ethernet of a coax. You just add a bridge there or a Wi-Fi extender, it's up and running. You can install it in an afternoon. It's really that simple. So you can provide Wi-Fi extension, Ethernet extension, and it's plug and play. You can add and remove boxes, you know, as and when you wish. So anyone who's going in and doing sort of domestic jobs, etc., anyone you spot with a games console, smart TV, etc., there's an opportunity here, and you can really enhance what's going on in their home. And you won't get the trouble calls a week later saying it doesn't work anymore, because, you know, it's good old reliable coax. The other side of the coin is the to-the-home network, or distributed Ethernet over coax. Now this is obviously slightly different. We're using a network controller, something like the likes of the top there, where everything is actually using a tree and branch or distributed system cascading down through a network of splitters, etc., so that each apartment, hotel room actually has its own discrete connection. And the device that you're putting on the end there, the Ethernet coax bridge, is actually only reporting back to that central controller. So what's going on in room A, that box can't talk to his box, so your data is completely safe and secure in the same way as a normal internet connection would be. We can now actually run up to 252 clients on one network, sharing a total of 800 megabits per second of bandwidth. And that's using a 200 megahertz, 450 megahertz channels to do that. And the bandwidth per client is fully controllable. The controller just has a very simple IP login screen, so we can either just equally apportion bandwidth to each client, or we can guarantee bandwidth. We say, okay, in those rooms I want a minimum of 20 megabits per second always, and then divide it up between the rest. For social landlords, social housing, etc., where you're charging for that service, you can actually block and control access, so if people stop paying, you can turn them off. We can even go down as far as a sort of blacklist and whitelist, so we register, it automatically registers the MAC addresses of each device that's been added there, and you can prevent unknown boxes being put on there. So if someone decides they're going to go and buy a box from eBay or Alibaba or whatever and plug it in, you can actually prevent them joining the network. Very, very simple management tools. And those are again available either as just an Ethernet connectivity, or obviously more commonly with a Wi-Fi connection as well. A very, very simple way of upgrading, you know, a hotel such as this, putting Ethernet and Wi-Fi into each room, just using the TV system. And the very, very simple rule of thumb, I think in some of the other presentations has already been mentioned about you need to do a site survey and a look around. The very, very base rule of thumb with this, if the RF system and the coax supports a DVB-T picture and you can watch it for 5 minutes without it all going into sparklies and falling apart, etc., generally you're in with a fighting chance. Because again, this is designed with a retrofit in mind, so you've got 80 dBs of dynamic range to overcome all of those nasties that happen along the way. So a typical to-the-home network, again we've got an RF signal, we've used an aerial there coming into the box, obviously we've put it in an amplifier housing. We've got our main cable modem Ethernet insertion there, laptop just showing that we've got a management screen so that we can go in and do the configuration and settings. Pretty much out the box it's plug and play, it's only if you want to start tweaking it, and you can prioritise traffic for voice over IP, it's got IGMP snooping, etc. there as well for that sort of thing. We can turn those off and optimise it all for video bandwidth, whatever we want to do. Whereas by default it just takes a look at what's going on and will automatically apportion the bandwidth out there. And then we've got our diplexer in there, which is passing the RF signal through our network of splitters. So in the first house there, as you can see, it's just getting normal TV pictures. In the second house and beyond, we've got an Ethernet to coax bridge. So we're providing Wi-Fi and then an Ethernet connection to the smart TV, etc. And that then can be repeated in 250, obviously, other houses as well on the network. It's very, very straightforward. So the installation, once you've done the physical install, plug that in, powered it up, you get an indicator light on there to say it's got a coax link, it's seeing the network controller. You can then leave that property, leave that hotel room. So it takes really about the same amount of time to install as you could follow the room cleaner in, disconnect the cable that's going in the TV, power it up, plug the coax cable into the box, then put a fly lead from the box to the TV, walk out the room. Everything else can then be done remotely. With the later versions, or the newest version of this, we can even provide SNMP management, so you can manage the network controller remotely. You can set alarms to see when things have been unplugged, disappeared off the network, etc. It's a very manageable solution. Let's say you've got total security with this, so a through-the-home network is sharing, it's a mesh network. This gives total security between all the boxes so that you can't see your neighbour's traffic, etc. It's designed for that. So typical applications, MDUs and apartments, etc. And this technology actually came from, apart from being made in China, was actually developed in China. When the Chinese government built those lovely apartments that all the Chinese people live in, they were only really provided with a coax network for watching the 2 or 3 channels of state television, pretty much all the same, just in sort of different time frames. Obviously nowadays people want telephony, they want Ethernet, internet, etc. Rather than trying to rewire all these houses with coax, with twisted pair and fibre, etc. This technology was really developed to utilise exactly what we're talking about here, the coax. So at the moment there's something like 8 million deployments of this technology in China and growing every day that we know of. But it's also being used hotel rooms, student accommodation, hospitals, schools, etc. Student accommodation is a very big one because previously you had a couple of Wi-Fi routers, students were accessing a bit of email, a bit of web surfing. Nowadays everyone's using iPads, they want reliable Wi-Fi, you need greater density of coverage. This is probably the best way to do it. You know, student landlords don't want to spend a lot of money, they're not going to run to ripping it apart and putting Cat5 cable, etc. in. So you've got a very, very simple method of doing it. For bigger systems, we also have DAR, or DOCSIS Access Hub, which is then using a cable TV type platform, a mini CMTS, if you like, a cable TV network in a box. So that we're actually using a standard DOCSIS system. We're then running that out through, we can run it through great distances, amplifiers, nodes, etc., so that we can run to bigger buildings. And currently we can support up to 120 cable modems. That's about to change up to 200 with the next firmware update. And that's then using just standard Cisco or Aris cable modems, again, to deliver Ethernet over that coax system. So that's more suitable for applications where you have longer cable runs, lots of amplifiers, etc. But again, comes back to having that standard distributed coax system for MDUs, hotels, etc. Again, a very, very robust system. But it all comes back to the fact that it's using the existing coax that's there. Difference as well with the DAR system, it has its own RF amplifier built in, so it's a completely self-contained system. You just need to provide either a fibre link or an Ethernet link to it, put it in the head end or put it in the street cabinet, and then off you go. So it's a variety of uses for that. So, a summary of where we're at. Obviously coax is very robust, as we've seen. It's probably the most reliable and most tried and tested method of delivering Ethernet traffic. You know, it's got huge amounts of bandwidth. Unlike things like home plug and power line alliance technology, it's completely shielded. So you can have all sorts of other things going around on it in the building and so forth, but it's completely shielded, so it responds. It's got much greater immunity and rejection to interference, whereas some of the HPNA and power line devices are using unshielded power cable. They're really only point-to-point devices. Great for what they're designed for, again, internet, web browsing, etc., low-speed data connectivity. The moment you start trying to put video, etc., down, then we'll run to multiple access points, multiple clients. Really, you know, it doesn't do the job. We can save cost, time, disruption, and coax goes right to the point of delivery as well. You know, if you want to get IPTV to the TV, lo and behold, to make the TV work in the first place, you had a coax point. It's probably easier to locate than even power sometimes. And almost all homes, MDUs, private landlord blocks, hotels have some sort of TV system. You know, you've got to go to a pretty desperate place where they're still using portable aerials lashed to the balconies, etc. And as someone pointed out in the last session, over the last few years there's been a massive upgrade in coax networks for the digital upgrade and switchover. So most places are in a pretty good state because they've been upgraded with the digital switchover. But as I say, if it supports DVB-T network at the moment, or DVB-C if it's cable, stable picture with not too much loss of picture and service, then you're good to go. And we can add obviously quite a lot of value add perspective for our clients, because we can say, well, okay, I can provide you Wi-Fi, I can provide Ethernet, I don't need to actually start ripping your building apart and adding loads of bits and pieces to it. So that's really a kind of a summary. Because you've not asked many questions, and I think we've got 5 minutes left. 5 minutes. Does anyone have any questions or comments? Or?
Yes.
Good.
The splitters, many splitters in homes cut off at 1,000 megahertz.
Mm-hmm.
Is that a problem in the system?
No, hence why it has the higher dynamic range, so it will overcome the isolation in those splitters.
And also, your various trees from the central point, that central point is likely to be a distribution amplifier.
Yes.
So does it get back through the...
You would put the
connections?
you would put the network controller after the distribution amplifier.
No, I'm talking about the standard home system.
Okay, the standard home system.
We haven't got a control.
Okay, standard home system, again, you're actually connecting the, before you go back, oops. Okay, if we go back to the, well, we've put splitter there, that will be typically a distribution amplifier. Aerial signals coming from the roof in, you have the amplifier, and then if you broke that box apart, there tends to be just a 4-way, 8-way splitter in there. That's where you're connecting, so the signal is coming back up the coax, obviously it's a duplex 2-way signal, hitting that splitter and just propagating across the splitter, so it doesn't affect that.
Right.
You don't need to put that first mocker box into the input and pass it through the amplifier, etc. So theoretically, you don't even need to go into the loft and change anything. You just use the exact wiring system as it is. The only time you might need to do a little bit of changing around is if someone's got an RF2 return path from a skybox, which is the only feed from the living room because they've only got one coax cable, which is currently at the moment going into the amplifier as a second input. You may just need to put a splitter so that on the first leg it's still going into the amplifier for the RF distribution. The second leg is just being connected to one of the outputs to carry the Ethernet over coax data. That's
that wouldn't confuse everything really.
Sorry?
That wouldn't confuse everything really, not to go in and out.
No, it doesn't. It's fine. Because you've not got enough signal level to cause any problems with that. So you just need a spare, potentially a splitter and a spare outlet on the amplifier. Yes?
For that system to work correctly, the amplifier within the DA will have to go high impedance above 1 gig, so you can't guarantee that for any installation. In fact, cube and chipple ones, generally speaking, they just tail off. They don't have much in the way of filtering.
Yeah.
If it doesn't go high impedance, you can't guarantee that the return path through the splitters will function.
The amplifier is in front of the splitter, so all we're actually doing is the return path, if you like, from the first box is only actually going to the splitter. It's independent of the amplifier.
But the amplifier, in that scenario you've illustrated there, that box presumably has the amplifier and splitter network built in.
Yes, it does.
So how are you able to interrupt the signal between the amplifier and the splitter network there? It's all within the same box.
If you break it apart, what you would see is you have the amplifier stage and a single output from the amplifier then goes into the splitter.
Of course, but you don't want the installers to be taking boxes apart, hacking at them with a soldering iron.
They don't need to touch, they don't need to take anything apart. You're just simply connecting all of the mocker boxes purely to outlets of the amplifier.
Correct,
of the splitter,
but if
yeah.
the output of the amplifier block itself is reasonably well matched to 75 ohms at your whatever it was, 1.15 to 1.5 gigs, then your splitters should do a fair job of preventing the mutual interference, which is what it will appear as, between those outlets.
Okay. The mocker signal is robust enough and you have enough dynamic range to actually overcome the port-to-port isolation on the splitter. That's part of the sort of blueprint design, if you like, of mocker, to be able to retrofit it. So you can actually just plug that in and it works. It's designed to be, so as you say, you don't have to start taking things apart, attacking stuff with soldering irons. It's just purely a plug-and-play solution. So, yeah.
You presumably get about 25, 30 dBs of isolation on the splitter, so
yeah.
you can overcome that.
Yeah, you've got 80 dBs of range.
You can guarantee 25 or 30 dBs isolation, but it may well be considerably better at some frequencies.
Let's say if you...
In our house, we have other inline amplifiers. Presumably, it's not going to go through those backwards.
If you have an inline amplifier, then the mocker signal won't, because obviously they tend to clip the signal at 1 gig. The very, very simple workaround solution for that is to put a diplexer and just bypass the amplifier. So you put we can show you that upstairs. Diplexer in front, bypass the amp, and then carry on. I'd say you've got 80 dBs of dynamic range within the mocker standard. That curve is fairly flat up to about 72 dBs, and it's really then a drop off in the last 8 or so dBs. So you can get pretty much full performance. Typically, the system I've got at home has, I think, 8 mocker boxes on it. The links, some of the links, because I've deliberately sort of dirtied it up and put some bits of coax that I found from the builder, etc., are running at sort of 60 dBs of 60 dBs of loss, and it's still performing at decent speeds, etc. So in most homes you won't find a problem. What you would find, obviously, with the domestic DVB-T system, if you had that much loss anyway, the standard DVB-T picture is going to be right down in the dirt. You know, if you look at even the signal meter on like an LG TV, etc., it's going to be showing orange or red, and it's going to be, you know, right on the limit, subject to kind of atmospheric conditions and everything else anyway. So you've got bigger problems to worry about.
Jason,
Yes.
I think you said this earlier, just to clarify. If you have to use the RF in, not the RF out. So if you're lucky enough to have an old skybox with RF2 supporting Magic Eyes,
Yes.
then use the aerial in.
Okay.
Skybox, you don't use the aerial back out.
I've got this at home, so basically, because I'm a cheapskate and I've not bought a ZeeVee amplifier yet, but we'll talk about that later. I've got RF2 coming out the back of the skybox, and there's only one cable that comes down to the living room because it's all been sort of plastered in by the builder, etc., and nailed to the stud work and everything else. So that cable is going back up to my loft distribution amplifier, and was traditionally going into like an RF2 input in that loft amplifier. Now the amplifier is obviously going to kill everything above 1 gigahertz quite simply. So what I've done, and what the standard thing to do, is put a splitter there. So the first leg of the splitter goes back into the RF2. The second leg is just connected to an output, so the mocha signal can then propagate across the splitter and back out to the other legs, and that works perfectly fine. Any other questions? Okay, good. So we've got some equipment upstairs set up and running, so if you want to come and have a look and a poke and a prod and a play with it, then do feel welcome. Thank you.